Hello students. Now let us understand another sorting algorithm technique, that is insertion sort. So let's first see the algorithm for insertion sort. So in an insertion sort algorithm, we pass the array having n elements. So it's the array name and the size of the array. Now for insertion sort, we will require two nested loops. The outer loop runs for k equals to 1 to n minus 1, which means the second element. Okay, so we are starting with the second element and we are going till the last element, which is n minus 1. And we're going to repeat step 2 to 5 for this process. That means step number 2, step number 3, and step number 4 and 5. These 4 steps will repeat for k equals to 1 to n minus 1. Now, let us understand that for every step where k is incrementing from 1 to n minus 1, what we are going to do. So, when k is ranging from 1 to n minus 1, for each iteration of k, we will assign the value which is pointed by k into a temporary variable. So, set temporary equals to array of k. If you say, let's say initially k is 1, that means we are storing the first element, the element which is at the first position, the element which is at the first position into temporary. We are going to use another iterative variable which is j, and this j is going to point to one location previous to where k is pointing. So let's say k is pointing to 1. Okay, so if k is pointing to 1, so j is going to point to k minus 1. That means one location previous to that location. And once we set the value of j, we're going to repeat the next two instructions till the value of temp is lesser than equals to array of j. So as I mentioned, j is a pointer that lies before k pointer. So we have to keep, decrementing the j pointer. So basically it's like in an array, j goes to the left side, whereas k goes to the right side. So if there is an array and let's say k is pointing to the first location. So let's say this is k. So j is exactly the previous value, right? And whenever we are comparing, so whichever location k is pointing, we put it in the temporary variable and we compare this value, temporary value, with the j value, that means the previous values. And what we are basically doing is that if the order is not maintained, then we are shifting the number. Now, which number we are shifting? The number that is pointed by j, we are shifting it to j plus 1. So you can see set array of j plus 1 as array of j. It means if the order is not proper, we shift the j value. And we keep doing this if we find that the temporary value which I have set is lesser than the value of j. That means any value which is pointed at by k, if this value is actually minimum value from the all values to its left side, we shift all these left side values to right side so that we make a place for this value, which is the minimum value, and shift it backwards. Okay, and then what we do is whichever empty space that we get, because we have started shifting the numbers to the right side. So there will be an empty space towards the left side of the array for that particular number for which we are searching the position. We will shift the temporary value to that, but it will be always j plus 1. Now, to understand this algorithm in a better way, let's first understand the problem. Again, I'm repeating here. We set array, we set the two loops. The outer loop, which is a k loop, it starts from 1, it goes till n minus 1. That means it always starts from the second index. And the previous index is always j, right? And then we take the value of k into a temporary variable because we're going to shift the numbers to the right side. So it may happen that we're overwriting the numbers. And that's why we have to take the value which is pointed by k into a temporary variable. And then we compare this value with all the left values. if any value is greater than this value, we shift those values towards the right. So basically, whatever value is pointed by j, it goes to the right side of the array. And that's why we need a temporary value, a temporary holder basically to hold that value which is pointed by k. Now to understand this problem, let's take the actual numbers and we'll see how the shifting happens. So let's understand here. Let's take the first iteration where our k is 1. So as I mentioned earlier, k starts from 1. Okay. So here, at whichever value the k is pointing, we have to take it in a temporary variable. So here, if you see, k is pointing to 67. So these are the index values: 0, then this is 1, this is 2, this is 3, this is 4, and this is 5. So as mentioned earlier, k is pointing to 1 because it starts from 1 value. And then this value will be taken in the temporary variable 67. So now we want to find out if there is any value to the left side of 67, which is actually, greater than 67. So that we have to shift the numbers. That means we have to shift 67 to this side, and any numbers which are greater than 67 should come to right side. But here if you see, this is k value, which is in the temp, and anything before that will be j. So we have only one value, which is 34, and j is pointing to that. Now our algorithm is, we have to repeat the step for k equals to 1 to n minus 1, and in that we have to set array of k as temp, and we have to set j as k minus 1. So this we have done. Now our condition is while the temporary value is lesser than a of j. Now here our temporary value is 67. Is it lesser than equals to array of j? Array of j is 34. Now this condition becomes false. And because the condition is false, what we do is, so if I show you the array, so this condition itself is false. And therefore we come back directly to line number 7, which says we have to store the temporary value to j plus 1. Now please pay attention here. When we were comparing here, right? So this condition becomes false. And therefore, when we are comparing 67 with j, and if this condition is false, we perform set array of j plus 1 as temp. So if this is j plus 1 is this position itself. So we are storing 67 back here. That means if in the initial time, if there is no, if the order is correct, then your 67 is at the same position, right? So the number is not shifting anywhere. The number is there itself. So you copied this to temp, and from temp you're copying it again back to the same location. So it's 67 only. Now let's understand the second iteration. Now in second iteration, what will happen? This k should come here, and then j will start from 67 to the reverse side. So let's understand this. Now in the second iteration, k is 2. And if k is pointing to second index, which is this, that means the temp is 12. That means we are looking for this number. So we want to see that any number, if it is greater than 12, we have to shift those numbers to the right, and 12 will go to the left. That means this number has to go this side, right? So this number, so this number has to go to the left side, and the bigger numbers should shift to the right side. So the condition here is if the temp value, which is 12, if it is lesser than array of j. Now array of j is 69. So 12 is lesser than equals to 69. Yes, the condition is true. So what we do in that case, we are setting array of j plus 1 is equals to array of j, which means array of j, which is 69, is stored at array of j plus 1. J plus 1 means the next location. So we are simply shifting this number here. That means if you see, 12 will get overwritten. So 69 will come here. There will be blank space at this place. So the next iteration, what happened is 69 shifted here, which was pointed by k. And now this is an empty space. And at the same time, our loop is also decrementing the value of j. So in earlier case where j was here and we shifted 69, j got decremented because it has to go to the left side, right? J will go to the left side, k will go to the right side. So now 69 is shifted here, which is this case, and j has been decremented. Now the same loop will work because we have to keep running it till our j goes beyond 0. So here again check if your temporary value is lesser than array of j. What is temporary value? We were checking with 12. So is 12 lesser than equals to array of j, which is 34? Yes, again the condition is true because I can clearly see 34 is greater than 12. So 34 should come here and 12 should come. So we need to again shift this number to j plus 1. So j is shifted to j plus 1. So 34 will now come here and j will decrement. So j will become minus 1 now because it is already 0. So if you are decrementing, it will become minus 1. So in the next step, what will happen? 34 is shifted to the right side, which is j plus 1, and j has been is decremented to j minus minus, which is now j is minus 1. Now, this is the stopping condition because our loop runs, if you see, our loop runs only for this condition, and once this is done, that means once the j loop gets over, we are supposed to store the temporary value to j plus 1. So if j is minus 1 now, j plus 1 will become j as 0. And at this location, we will store 12. So after this, 12 will be stored here. Now, if you see this, the value from j plus 1 to k is the sorted array that we got, right? So 12, 34, 69, they got sorted. Now we have to repeat this for the remaining numbers. So let's understand. Now k will shift because this iteration is over. Now k has to go for the next value. So it will be the third iteration where k is now pointing to index 3. So now this is index 3. So wherever k points, j has to point one value previous to that. So now j is pointing here. So and wherever that k is pointing, we have to store it in a temporary variable. So 5 has been stored in a temporary variable. So we're going to compare this temp with all the values which are pointed by j. So 5 will be compared with 69. So if you see 5 is lesser than 69, yes, it is true. So what we do? We know that this number should not come here because 5 should come before that. So we will shift this number to right side. Yes, so after this 69 will be shifted, and at the same time when we are shifting 69 to the right side, j has to decrement. So 69 goes to right side and j decremented, and it is now pointing to 34. Again the same loop works. Here 5 is lesser than 34 also. So this number should not come here. It has to shift towards the right side and j has to shift towards the left side. So 34 goes here and j comes here. Again, 5 will be compared with 12. So 5 is less than equals to 12. Yes, condition is true because 12 should not be here because 5 is lesser than that. So 12 has to go to the right side and j has to get decremented. So after this, 12 will come here and j has gone beyond 0. Now this is the stopping condition because j is out of loop. And here at this point, you perform j plus 1, which means you come to this position, right? And you store 5 in that. So now 5 has come to this position. And now at this phase, you see that these 4 numbers have been sorted. Next, we increment k. So now k will go to the next iteration. So it is the 4th iteration that we are doing. So k is 4. That means k is pointing to 10. So 10 will go to temporary variable. Now this 10 will be compared with all the previous numbers pointed by j. And whichever number is greater than that, we will keep shifting to right. So you can see 69 will go to the right because 10 is lesser than 69. So 69 will go to array of j will go to array of j plus 1. So array of j will go to array of j plus 1. So 69 came here and j got decremented. Again, 10 is lesser than 34 also. So here 34 will go to the right and j will decrement. So 34 is going to right and j is decrementing. Again, 10 is lesser than 12. So 12 will go towards the right and j will go towards the left. So 12 came here and j is here. After that, 10 is lesser than 5. Now this condition is false because 10 is not lesser than 5. 10 is greater than 5. Now this is the stopping condition. Now once this condition is false, what we do is we store the temporary value into j plus 1. So already in the previous case, j was here and we are comparing 10 with that 5. And this condition is false. That means the location which is empty, there we have to store this 10, which is j plus 1. So at the location j plus 1, we are going to store value 10. So 10 comes over here. Now at this case, you see the value from j plus 1, j to k are all sorted numbers. And same we do for the 5th iteration where k is pointing to the 5th element, 6th element. This number will go to the temporary variable and we'll do the same thing. 8 will be compared with 69. As 8 is small, 69 should shift right, J should shift left. So here 69 will go right and J will come to left. Again, 8 will be compared with 34. Because 34 is also greater than 8, 34 shifts to the right, J shifts to the left. So 34 comes here, J comes here. Again, 8 is lesser than 12, so 12 will go to the right side and J will go to the left side. So 12 comes over here and J is decremented. 8 is lesser than 10 also, so 10 will shift to J plus 1 and J will decrement to J minus 1. So 10 comes here and now because 8 is not lesser than 5, so that condition becomes false. So we're going to store the value of 8 at location array of J plus 1. So J was already pointing here. So at location J plus 1 is this empty space where we are storing the temp value. So this is your final array, which is a sorted array after performing insertion sort.